Okay, we're looking at tangents and normals here. Now, if I was to draw a curve, all right, here's a curve, right, and I had a point, well, where shall I put my point? I'll put my point there. Okay, a tangent would look something like this. Okay, it touches the curve at one point. A normal looks something like this, right, meets the tangent at right angles, so it's perpendicular to it. So when we look at this gradient of tangent, nice and easy, to find a gradient, we find dy dx, don't we? So dy dx equals, what's that, 3x squared minus 1. Substitute x equals 1 in, so the gradient is going to be 3 times 1 squared minus 1, which equals 2. Nice and easy. Now the normal, we've got to do the same start off. Okay, and we're finding the equation this time. So we find dy dx equals, what's that, 2x minus 5, there we go. We then find the gradient by substituting in minus 1. That gives me minus 7. So the gradient, so that's the gradient of the tangent. That's like the blue bit here. Okay, so the gradient is minus 7. Obviously it's down here somewhere, isn't it? Okay, so it's a point over there. Now then, that means the gradient of normal, is the negative reciprocal, because it is the negative reciprocal, so that is going to be a seventh. And then I'm going to use y equals mx plus c, where x is minus 1, y is 4, and m is a seventh. Okay, so I'm going to go 4 equals a seventh times negative 1 plus c. Work all that out, you end up with c is, I think it's 29 over 7. Let's have a look. Yes, it is 29 over 7. Okay, and then my equation is going to be y equals a seventh x plus 29 over 7, 29 over 7. All right, which might be written actually as 7y equals x plus 29, multiply 3 by 7. Okay, so just remember, tangent is the gradient, of the curve at that point. The normal is the perpendicular to the curve, or perpendicular to the tangent, I should say, at that point. Okay, enjoy.